All right, everyone, welcome to this impromptu online lecture. So in the lecture today, we're going to be introducing another technology built on top of R to sort of supplement what we were doing with Cordo. This is called Shiny, and so it's an R technology. It's really useful for data science type applications, and like Cordo, what it's going to let us do is help to communicate different ideas statistically. And so it's going to sort of let us build different applications than what we could do with Cordo, with sort of this focus on building these interactive web applications. And so we'll sort of talk through the structure of a Shiny app, what actually we sort of need to do in order to build these out, and introduce sort of the main ideas, the main concepts here, and then hopefully that gives you the tools you would need to go forward and start experimenting with this and playing with this on your own. I will say that before we get going, my apologies if there's lots of sort of background noise in the lecture here today. There's a whole lot going on here, and so we'll try to sort of push through this together. So these slides are available on the course website, and so feel free to follow along there. There's also the Cordo document that produces these slides in case, one, you want to see sort of what that looks like, but then also you can generate these out to be a set of notes rather than a set of slides, if that's sort of an easier reference for you to hold on to. So Shiny is ultimately an R package, right? It's an R package that allows us to do interactive web development. And so because it's just an R package, you can install it like you would install any other external R library, right? So we can call install packages Shiny. You can use the RStudio built-in package manager to install it. Sort of any way that you would go about installing an R package, you're going to be able to install Shiny that same way, right? So I'll assume that you're able to get Shiny installed and that it's going to just be running, doesn't require any other external resources. If you want to see some examples of a Shiny application, we've actually looked at one already. So there's this sampling distributions application that I've shown a couple of times in class and that I've included on some of the assignment instructions. And so that sort of will give you a feel for the types of things that you can do. It's a fairly basic application, but it will give you a good sense of what's possible and what should be possible by the end of the lecture today. There's also this getting started tutorial that I have linked here in the slides. And that's actually provided directly by Shiny, or by the people who make Shiny, I suppose. And that's going to cover the same material we'll cover today in class, but they also sort of have these exercises that you can work along with in that tutorial. And so that's sort of a good way to make sure that you're sort of understanding things if you're finding it challenging to sort of follow along with what we're doing in the lecture directly. So we'll first introduce the sort of structure of a Shiny application, then we'll talk about each of the components of those a little bit, and then we'll talk about some sort of more advanced features or some other stuff that we should know. Ultimately, a Shiny application is created using a single R file, right? Sometimes you'll see it made over the course of 2 or 3 R files, and oftentimes you're going to need other R files to supplement what it is that you're doing if you're trying to do something that's a little bit more complex. But ultimately, with one R file, you can make a Shiny application, right? So we'll start there and we'll sort of assume that everything's going in the same file throughout the lesson today. So you can make, for instance, an app.r file, right? So oftentimes we're going to call this app.r. Sometimes you'll see someone calling it server.r or UI.r, but we'll sort of use the convention app.r. This is sort of standard practice in the Shiny app or in the Shiny ecosystem. And the idea is that you want to put it into some directory. And the directory is going to house all of the files from your app, right? So you can call my Shiny app, whatever else, right? So it's this folder. Inside that folder, you're going to have app.r. And that's sort of the basic setup. Any time that you'd want to sort of add additional items to your application, whether that's image files, whether that's external R libraries, whether that's a data source, you're going to want to put it into the same directory here. And then that way, everything that's inside that folder sort of can be transported around as the application itself, right? So you don't want to be referencing files that are somewhere else on your computer, because then if you go to sort of make this available to others, that's not going to still work out there. Inside the app.r file, there's going to be 3 main components that we're looking for. So the first is a user interface, or a UI object. And so the UI object is going to control what's actually on the screen. What is it that we're seeing? What is it that we can interact with? What's being output to us? So it's going to actually just lay out the application, the whole web page, right? And we can specify this all in our code, but it's going to tell us, there's a button over here, there's some text here, you can do this input, a plot gets output over here, we have this navigation bar, all of these types of things are specified through this UI object, or this user interface object. Then there's a server function, and will literally be a function in R, and it's going to take a couple of built-in parameters. And the idea with the server function is that we want to hook up the user interface to whatever logic we want to perform, right? So when the user presses a button, we want to do something. When data gets loaded in, we want to produce a plot, right? So all of these types of things that you want your application to actually do are going to get stored in a single server function, right? And so we'll see sort of how that all gets built out. And then ultimately, what you have to do is simply call this built-in Shiny app function. It's built into the Shiny library. And what that's going to do is it's going to take your UI, take your server, and combine the two of them together. And it's going to provide you a lot of the interactivity for free, right? So you're not going to have to sort of hook any of that up as long as you've built out your UI and your server function correctly. So sort of as an R script, right, we'll load in our library here. So we're loading in Shiny. Then we want to define our UI, right? And so, for instance, we might use it with a fluid page call. We'll talk a little bit more about what that is, but we'll define some R object here. It's called UI, and it's the result of some call to a function, right? And then we define the server function, right? So it'll be the server. It's literally an R function, right? So it's just, you get the function keyword here, takes the input and the output, and we'll talk about how all of this works out, but just a server function. And then we call Shiny app, and Shiny app takes in the UI and the server, and it actually produces our Shiny application here, right? So it is just, we have to talk about defining the UI, we have to talk about the server, calling the Shiny app is going to build out the application for us. So you can then sort of, once you have that all built out, once that app file exists, then you can call run app and provide the directory to it to actually run your application. If you click the Run App button in RStudio, it will automatically take care of this for you. The parameter that we pass, so my Shiny app, for instance, is the directory name where your application actually lives, right? So it's important to have that all contained inside of an application, and then Shiny will take care of the rest. It will actually, start up a web browser for you, allow you to actually look at this, and then we'll talk about how you can make this publicly available a little later on. Okay, so now we'll talk about each of these components together, right? So to start off, how do we go about building out the user interface? So ultimately, Shiny is going to rely on building out an HTML page for the layout of the document. Now, if you know HTML, it becomes very familiar to sort of build out your Shiny application using HTML. However, we can do this all directly with our code. So if you don't know HTML, that's totally okay. Everything's sort of very intuitively built in to R directly. And specifically, it's built into R through the Shiny library, right? So inside of Shiny, there are all sorts of function calls that will produce these different HTML objects. And that's what we're going to rely on predominantly. For doing this, there are some other ways about going about this if you want to do a little bit more advanced work, but this is sort of the standard here. So we saw sort of on the introduction, this call to fluid page, right? And so the fluid page sort of will allow us to specify the bulk of our layout and sort of start putting components within it, right? And so what fluid page means is that we want to create a web page that's going to be fluid based on the size of the window, right? So this is sort of, if you're on a mobile device, it will lay out things differently than if you're on a web browser. And so almost always you're going to call UI, pass the fluid page, and then you're going to start putting components within your fluid page function. This is sort of the basic default. There are alternatives, but again, as a general rule, fluid page, unless you have a good reason to not use it. And so within fluid page, you start putting components on the page, right? So you could, for instance, put in a title panel and, maybe give it my application title. And this is going to put a title that's sort of well formatted at the top of your document there. You might provide it with this call to sidebar layout, right? And so what sidebar layout is going to do is it's going to actually start laying out the page, and it's going to give you this ability to have a bar down the side and then a main component, right? So it provides the layout for your sidebar and then your main area. And within that, you're going to provide what goes in the sidebar panel and what goes in the main panel, right? And so within your fluid page, you might want to lay out your document as though it's this sidebar main panel. And then within this sidebar panel and this main panel, you'd start putting the different elements from the page, right? So it sort of specifies one version for a layout. You might also want a navbar layout, right? So there you're going to have a navigation bar along the top of the page and then sort of your main body beneath it, right? And inside of a navbar layout, you could then put a sidebar layout, right? And so you can sort of nest these things within one another, and all of this is going to be nested inside of our fluid page. You can also use fluid row or fluid column. And these are going to let you, instead of using sort of these built-in different options, it's going to allow you to actually specify a row or a column nested within one another. And so you could say, you know, I want something that's going to take up 1/3 of the screen, and then something that will take up 2/3 of the screen, and then a new row, and, you know, 1/3, 1/3, 1/3, a new row, half and half. You know, whatever else you need to do here, you can accomplish sort of custom layouts with fluid row and fluid column. If I'm honest, a lot of what we're going to be doing is going to very naturally fit within this sidebar layout. And so a lot of what we'll do sort of will start here. At some point, you might want to include the navbar layout as well. And then once you get really familiar with this and you sort of start having these visions in your head of what a Shiny app might look like, that's when I would start playing with these fluid row and fluid column calls. So this sort of allows you to lay out the page, right? This is just telling us where our item's going to go, but this doesn't, other than this title panel, doesn't really put anything on our actual page, right? And so we need to be able to specify the content or the components that are actually going to go on the page. And so HTML components are almost all sort of programmed directly into Shiny, or at least all of the major ones that we're going to care about. And so the idea here is that once you have sort of your layout, if you want to put something in your sidebar, you would start calling these component functions within that sidebar layout, right? Or within your main panel layout, for instance, right? So, for instance, we have the paragraph tag, the heading 1, heading 2, up to heading 6, and the span tags, right? And if you're familiar with HTML, all of these are just text containers, right? So if you call P, then you can pass in a text string, and that's just going to have sort of normal text on a page. If you call H1 and you pass in a text string, that's going to have sort of your top heading, and then H2 is your secondary heading, and up to your 6th heading. Span is a way that you can end up sort of specifying some custom styling for different text, right? So it's going to allow you to say highlight text or sort of, you know, set it apart in some way, change the color of it, these types of things, right? And so you can wrap it in here if you need to start styling your text as you would like, right? We can also use sort of the built-in text styles, right? So strong is the function to bold text. And so you could call P, which is going to allow you to specify a paragraph, and then bold some of the text within your paragraph tag. M here is the emphasis or the italicizing function, right? And so same thing. You could call P, have bolded italics text by nesting your M inside your strong inside your P. Right, for instance. This pre function is going to allow you to sort of specify text exactly as it appears, right? So it's going to maintain all of the white space. It's going to maintain however you exactly lay it out, right? And so this is useful, for instance, if you want to include some code. There are other ways of doing this as well, but you know, it's a useful tag sometimes that comes up. We then have sort of the standard container tags for HTML elements, right? So our div is just our big overarching container, right? If you want to just group some stuff together, a div is going to be the holder that we want to put it in. And so you could call div, and then inside that, maybe you put a P tag, or you probably start with the heading tag, right? H2, name of the section, and then some paragraph text explaining what exactly is going on there, etc. The IMG, or the image tag, is going to let you include images, right? So you can include the image tag and then specify what image you want to include. A is the anchor tag, so this is going to let us include links, right? So you can include the link with the text and then wherever you want to link off to. And you could, again, put this inside of a heading. You could put this inside of a paragraph. You can put this inside of anything else. The BR tag includes a line break, right? So if you want to make a new line, then you can do it with the BR tag. HTML allows you to include any other HTML code that you want directly, right? So you can just include this HTML tag, pass it a string, and it will parse this as HTML, right? So if you already have some layout, if you find something online and you're like, I want to include this directly, I don't sort of see the components to do this, you can just do this straight up, right? So all of these components here don't really have anything to do with the interactivity of our app, right? These are going to let us put text or other elements on the page that are sort of perhaps important to lead someone through, to communicate the different ideas, but these are not going to be the things that the user's actually sort of interacting with, right? And so this is sort of our standard layout. And again, you're going to be putting these inside of the layout containers that we saw on the previous page, but this isn't sort of building out the application, right? This is laying out our application. It's also important to note that the attributes for these HTML items can all be specified as named parameters to our function call, right? So if you've seen HTML before, you'll know that oftentimes you want to provide specific attributes for these different tags. So for instance, if you want to align something to the center, right? So we have this heading, it's my heading, I can pass align equals center, and now it will be center aligned text, right? If I have an anchor tag, right, this is the actual link that will show up, or the text that will show up for the link. You know, it's going to link out to google.ca, and I can specify this target equals _ blank. And what that's going to do is open it in a new tab, right? So, you know, you can specify all of these types of things together. Again, if you're referencing HTML online, right, and you see sort of answers that have to do with, you know, specify the target of the anchor tag, you can just specify that directly, and that's going to work out well. With an image, right, the source is where it's actually going to be, right, so myimage.png, but then you could specify the height and the width that you wanted to specify here, right, so you could do that directly inside of it as well. And so all of the attributes are going to be available via named parameters to our function call. So we've seen sort of laying out these elements, right? How do we actually get to user controls? And so just like all of the elements, Shiny is going to have a bunch of built-in controls. And these are going to be things that the user can interact with to set different values, and then we're going to ultimately be able to respond to those in our application, right? So how do we go about doing this? Well, they're going to be placed just like any of the other elements that we were just seeing with in our Shiny application, right? So for instance, we might want some buttons. We can have an action button, a submit button, or some radio buttons, right? So an action button is just going to be, you press it, something can end up happening. The submit button is going to generally be to submit data. So there's going to be sort of a slight difference here. Ultimately, if we want to interface with them, we can use sort of either one interchangeably for most of our purposes, but there's a slight sort of difference under the hood of how they're working. Radio buttons are those buttons that you can select one element for, and if you press another element in the list, then that element becomes selected instead of the first one. So, you know, you can sort of include all of these with them, right? Then we're going to have lots of different input types. So we can have date inputs or date range inputs, you know, where they're going to throw up a calendar and allow you to select sort of elements there. You can have them upload files to do something with. You can just have them enter in a number, or with this slider over here, you can end up doing sort of a slider version of entering in the number. You can have a text field. There's also this select input. The select input is going to be a drop-down list, and you can specify what options you want off of the drop-down list, right? So sort of very flexible ways of accepting all sorts of different types of data here. We can also have checkboxes, right? So if instead of using sort of a select, you want to allow them to select sort of arbitrary elements here, you can use these different checkbox elements, right? So lots of ways of including different data. We also have this help text, and this help text probably belongs technically on the previous slide, right? But I include it here because the help text is going to be able to be placed sort of next to an input and describe exactly what that input is. And it's sort of designed to go hand in hand, right? So it can say, you know, we want you to enter a number that's between these values that is going to ultimately be used for this thing, right? And so it's sort of useful to have when you're laying out the actual controls of your application here. Now, each of these function calls I think is going to sort of produce something that is somewhat intuitive based on the actual name of the function, right? So an action button is going to produce a button that will perform an action. A date input is going to allow the user to input a date and so forth. But each of the controls is going to require a couple of different things. So the first is a unique name to identify it. The very first parameter you're going to pass to it is the thing that you want to name it. The name is not going to be seen by the user of the application. It's only going to be referenced in the code, right? So it makes sense to give these sort of descriptive variable names, and then inside your code, you're going to be able to reference the different values from that directly. You also want to use a label, and the label is the thing that will actually show up for the user to see on the application. If you don't want there to be a label, you can just provide an empty string to the label, but otherwise, you could provide a descriptive name, and it will show up alongside the actual input there. And so the label should be descriptive, human readable. It's not your variable name. You can also reuse labels as you need to, right? So with unique names, labels can be reused. Then each of the different inputs is going to have some set of parameters to specify how they're controlled, right? And again, these are all just built-in R functions, and so you can use the question mark, type the name of the function to see exactly what is needed here. But as a general rule, they're going to be things that are sort of intuitive in order to be able to control the different input types here, right? So for instance, we could include an action button here. The action button's name would be action button 1, and then it would include the text press me on the label, right? And so you can do that kind of thing. If we wanted a numeric input, we might call it my num1, right? Sort of giving it a variable name. We can give it a label here where it's some number value. And if you see, we're actually putting our label in a header tag, right? So you can nest these things together. So that becomes kind of fun. And we're starting it with this value of 5. So by default, the value is going to be 5. And then the user could input a different numeric value as they need, right? So that allows for the input from the user, right? They're going to be able to select all of these different controls. We also want some way to specify the output for the user, right? So in order to allow for the interactivity, the basic idea is going to be the user comes in, they specify some things, something changes on the page, right? That's sort of the basic idea with these applications. And so what we will need is there to actually be these holders for the output of this reactive content, right? So if you want to generate a plot every time that the user changes something, right, which is sort of what's happening in that sampling distribution, then we need some place that's going to hold that plot. And it needs to know that it's going to be a reactive plot, right? We don't want to include just an image here. We want to include a plot that's going to update when the user changes the buttons. And so how do we go about doing that? Well, we need to specify these holders for this reactive output, right? So I'll refer to these as reactive output holders, and then they're going to ultimately be linked in the code through that server function to the user input, right? So just like the inputs, there were a whole bunch of them, and I think their names were somewhat self-explanatory. Same thing with the output, right? So you could have a data table output, and that's going to allow you to output this table of values, and it's going to give you sort of sorting controls and search functionality and stuff built into it automatically. You could have a plot output. It's going to let you output a plot. You could also just have a table output, right? So a table output is going to be a little bit more basic than a data table, but it might be more appropriate if it's not actually sort of a data set, right? If you actually just have a table that you want to sort of always remain the same, you don't want the user to be able to sort and those types of things. You also might be able to generate images on the fly, right? So perhaps you want to change the image based on something that the user has selected, or update some text, right? So if you're going to fit a model and estimate some value, you might want to output that value via text. There's also this verbatim text output, and the idea with the verbatim text output is that it's going to maintain all of the white space, do all of that kind of thing, right? So if you sort of have say a model output and it's sort of formatted with white space to make sure things are aligned, you could use the verbatim text output, and it will just put that in directly without trying to filter that down to something more reasonable. You can also use these two calls here, which are HTML output or UI output. And these are going to, again, let you sort of specify arbitrary values for your output. And they're going to, sort of allow you to construct up sort of more complex interactions, right? So if you don't want to just do an image, but you want to create sort of a whole HTML landscape of sorts, then you can use the HTML output, or if you want to output a single sort of UI element, that kind of thing, you can use the UI output as well, right? And so these are going to let you hold sort of more arbitrary elements within them. So if you're not sure exactly how to do what it is you're trying to accomplish, you can turn towards using these as sort of more powerful tools, but they require a little bit more effort on your part. All of the output widgets are going to require a name to be specified, right? So you're going to need to identify these in code as well, and you're going to do that with a unique name. So, for instance, you could call my text output on a text output, or my plot output on a plot output. You can also use sort of more descriptive names, right? But the idea is that you name the output, and you're going to be able to reference that name inside of your code to then sort of start hooking things up together. So, with all of that, that's sort of a very fast rundown of how you can build out the UI, right? So to recap, you sort of have these layout functions. The layout functions are going to end up holding components, and those components might be just sort of static components that allow you to specify text or images or any of these things, right? They might be input elements, which allow you to specify ways that the user can interact with the application, or they might be output elements, which are going to actually produce different pieces of output based on what's happening with your application. Right? And so you can lay out this all on the page. You can say, you know, my plot's going to go over here. The controls are all going to go in the sidebar. I'm going to have some text explaining exactly what's happening. You know, all of this stuff. Place it as you want. Once that's all placed, you know, you can load up the application and nothing is going to happen yet, right? And that's because we need to actually hook up what happens when the user presses buttons. How are we going to be generating the different plots? All of that kind of thing, right? And so all of that gets specified in our server function. Right, so we lay out the UI object, and then we turn to the server function. So the server function is just an R function, and it's going to take these two parameters. One of them is called input, one of them is called output. And sort of as the name should suggest, the input is going to map to what the user is inputting to the application. The output is going to map towards what our outputs are for our application. The ultimate purpose of the function is to build up the output object, right? So everything that we want to do with this server is to tell Shiny what code needs to be run in order to build the different output objects for us, right? And then what Shiny's ultimately going to do behind the scenes is figure out, okay, so this is how I generate this plot that you want here. When do I need to refresh this plot? And Shiny will know based on sort of how you've coded up that function when it needs to refresh the plot. And it's going to take care of all of that piece for us. So all we have to do is specify the code that we want to run in order to make our plot objects, or in order to, you know, make our text output, whatever else, right? So what code has to run to produce our output. Now, we're going to ultimately use these render functions, right? It'll be render filled in with some descriptive noun there. There are some other ways that we'll see exactly how to do this, but generally speaking, we want render functions. So we're going to have a render text function that will render text, right? And so these types of things. And what we're going to do is we're going to assign a part of the output object the result of a render function call. And from there, Shiny's going to hook up all of the stuff for us, right? So it will then automatically render when the app is loaded the first time, and it's also going to automatically update whenever it needs to be updated, right? And so this is why people like Shiny, right? All of this sort of background hassle gets taken care of for ourselves. So inside the server function, we would say, for instance, hook up the output of my text output to this is going to ultimately correspond to the text output that's labeled my text output, right? So when we're inside of the server function, output is going to already have this my text output, assuming that we've put this text output inside of our application, right? Similarly, if we've put this plot output inside of the application, inside the UI, then output will have this element, my plot output, right? And the idea that we're going to want here is we're going to ultimately need to assign the value of these, right? And we're going to assign the value based on these render functions. Okay, so continue building towards that. So each of these output elements, there's a corresponding render function. So there's a render data table, or a render plot, or a render table, right? And so all of those are going to correspond to the data table output or the plot output or the table output. There's also render image, render text, render print. These are going to sort of output the different text elements with respect to sort of the different inputs there, right? And then we also have this render UI, and render UI is going to allow you to specify HTML or UI elements directly, right? So we sort of have this one-to-one correspondence just about of all of these, right? And we're going to ultimately hook those up to the output elements. So how are they going to be done? Well, we saw previously that every time you have an output called on your specific UI, right, then there's this corresponding output $ element name, right? And so what we're going to do is we're going to take an output element name and specify that it needs to have a render plot, right? So my plot output is going to be hooked up to a render plot function call, and so forth. When we call a render function, all we're going to be doing is passing in these curly brackets and then putting in some R code that we want to run inside of that. It's sort of like defining a function, except you don't need to actually call it as a function. And so, for instance, we might just want to render this line of text here, right? So we want, we have render text call, open up the function call, include this bracket, and then just include a string here, and the function call here. Now, each time that this is going to be called, it's going to return the exact same text, right? So this isn't sort of interactive in any way, but this would work. And then we would assign this to the value of output, my text output, right? But you could do something a little bit more complex here, right? So we might call it the render plot function and then open up these brackets here again, right? But here, now we can define different variables, we can use different function calls, we can, chain together a bunch of logic, and then ultimately we generate out a plot, and it will be assigned to our plot output, right? And so sort of you can just include arbitrary code there, whether that's reactive or not. Inside of that expression that you provide is the code that Shiny will run in order to create the object that you actually want to display off to the user, right? So because of that, the value that you return there needs to match the value for the type of the element, right? So if you want to have a text element, you need to be returning text. If you want to have a plot element, you need to be returning a plot, and so forth, right? So it needs to match up because Shiny is going to run that code and assign it into the element. If you don't, you're going to get an error, right? So if it's expecting text and you provided a plot, it's going to give you an error on that. Now, what's going to happen is when you load up the app the first time, Shiny's just going to run all of that code and it's going to generate all of the output, right? So immediately upon load, it will start to fill in the different plots here. It's then going to run it again anytime that it needs to update, right? And so it will know when values have changed that need to be updated. I'm going to rerun this code, regenerate out these plots. So the idea with how Shiny knows when it needs to update is through the use of the input variable, right? So we saw the output variable is the thing that we're actually building up. The input variable in the server function is going to store the list of all of the inputs from the user, right? So for each one of those numeric inputs or text inputs or all of the inputs, those are going to be referenceable within our input variable. And then if we use the input variable anywhere, Shiny's going to know, okay, when this input changes, I need to rerun the code that used the input variable, right? So like with the output, the components are accessed via their name, right? So it'll be input, $, whatever you've named the element, right? So input my num would correspond to my num, right? Input action button 1 would correspond to our action button 1. Right? So you can access them in exactly the same way using their name here. And they're going to have data types and the different lengths sort of based on what you would expect, right? So the numeric is going to have a numeric data type. The action button is actually going to have a logical type as to whether it's been pressed or not, and these types of things, right? But they're all going to sort of have expected data types. And then any time that the values change, any of the code that relied on that input value is going to be rerun again, right? So if you use input my num1 in one of your, render text functions, whenever input mynum1 changes, that render text is going to be called again. Right? And so this is how we get the reactivity. Shiny's automatically going to hook these things up. So just by using this variable, you get all of the reactivity that you would want, sort of for free. So if we were to call output, my text output, right? It's a text output, so we use our render text function, right? Inside of it, we need to include the text code that we will actually want to render. I'm using this paste function. We didn't see the paste function yet, I don't think, but it's going to just paste strings together, right? And paste 0 both exist. The difference is paste 0 doesn't use spaces when it pastes things together. So we might have the paste, your number is, and then we reference the input, right? And so if you had your numeric input and you had your text output and you called this code, anytime the user changed what numeric input was input here, the text is going to update and read your number is what you have, right? And you don't have to do anything to make that happen. You just have to specify that the text that we want output is always going to be your number is whatever the user has input. Okay, and so this sort of gives you all of the basic features that you need to start building out these Shiny applications, right? Because you can specify your UI, you can specify your server function, hook things up together as you need, and then just by calling that sort of default application call that specifies the UI and the server, then Shiny's going to know exactly what to do. And I would actually encourage you to take this information and start trying to build out some simple applications, right? You're not sort of using any of the advanced features here. Some things are going to be a little bit inconvenient, but ultimately, this provides you with a lot of power already, right? So sort of just knowing you have to specify our UI, our server is going to hook it up. And really what you're doing with your server is you're connecting your inputs and your outputs through whatever logic you want to run. Now, despite the fact that this already sort of gives you a really good starting place, there are some more advanced features that we can look at, right? So, it's worth thinking about how code is actually run. So if we have sort of our Shiny application here, right? So we're specifying our UI object to be whatever it is. We specify our server function. And so then, we can think about where code goes. Any code that's not inside of our UI or our server is only run once when the application actually is loaded for the first time, right? So if you put this off to a web browser, the code outside of this is only ever run a single time. So you should use this place to put things like loading in libraries that you need, right? You only want to load those libraries in once, to loading in data files, to defining different functions, to calling all of your helper functions, to doing any background work that you need to do, right? All of the code that once it's been run once, it never needs to change again, should be run outside here, right? So this is before even calling the UI or the server. You can also put it after. I would just put it before. Okay, then we specify our UI, right? We've seen sort of how to do that. And then we have this server function call. Now, if you put something inside of the server function call, but not inside of one of these reactive functions, so not inside render text, for instance, then every time that a user visits the site, that code will be run once, right? So when the server is first loaded, then it will be run once. And so if you need to do any user-specific setup, then you should put code there, right? So if you want to, say, set a custom seed based on things, then you want to put that there. If you want to sort of start a unique session of sorts, then you'll want to put that there, right? And so this will be code that's run each time that the web application is actually loaded by someone. And then when you put text or when you put code inside of a render function, it's going to be run every single time that it needs to be updated, right? So every single time that whatever input variables are changed here, this code's going to run. And so you should only put code there that actually needs to be run each time, right? You should minimize the amount of code that you're running each time here, because you don't want to sort of be, if the user's just dragging around your slider, you don't want to be executing a whole lot of tedious code inside of your render functions, right? And so code that only needs to be run once, put it outside. Code that needs to be run once for each user, put it inside the server, but outside of any of the reactive functions. And then code that needs to be run every time, put it inside the actual render functions. Now, we've seen render text and how that allows us to generate sort of reactive text, right? Sometimes the code that you'll want to put into one of these render functions, whether that's render text or render plot or render table or whatever else, is going to be quite long, right? And oftentimes it's going to require sort of multiple steps, and some of those steps are going to need to be updated based on some input. Some of them are going to be needed to be updated based on other input, and sometimes you won't need to sort of mix those two together. And so when that happens, what you don't want to have happening is having all of that code have to rerun every single time, right? That's going to be computationally intensive. So for instance, maybe you have a plot, right? And one of the inputs is going to let the user dictate the limits on the plot, right? Where should the y-axis start and end? Where should the x-axis start and end? And then perhaps other input from the user is what's actually generating the data, right? And so you could do a render plot function where you take the generate data calls, right? And then you take the plot calls. And it's going to depend on the input that specifies what data should be generated, and also the input about where should the axes be, right? But the issue here is that if the user starts changing where the axes are, then we're going to call the generate data function again and again and again. And if that's sort of a computationally intensive task, well then just because the user is sort of wanting to see more or less of the graph does not mean that we should be regenerating these data all of the time, right? And so we sort of want to separate those things out. So how can we do that? Well, we can use what are called reactive expressions, right? And so these are all sort of more advanced features. We don't need to be using these, but they sort of help make your app more efficient when you start bumping into the walls of this, right? So when you have a particularly computationally demanding task, you might want to separate it out so that it only needs to run when it actually needs to run. And so we can use this reactive call to do this, right? And so essentially what we're going to do is we're going to define a variable based on this reactive call, and that variable is going to be reactive in the same way that the render functions are reactive, right? So it's going to update its value whenever it needs to, and then anywhere that you use it is also going to update when it changes. But then this way, it won't need to update if things don't change within it, right? So it's a smart interactive expression, and in particular, the important part is that the results of it are cached, right? So every time that you call this, unless something has changed with its input, it's just going to immediately return the value. It doesn't need to actually rerun. So you define it based on sort of, my reactive expression is a reactive call inside of these curly brackets, whatever you want to include here, right? And so in particular, you're almost always going to be including sort of this input element here, right? And perhaps this is, a very computationally demanding thing, right? So this could be our generate data function here, right? And then you're going to be able to use my reactive expression within the other calls, right? So my output text is now maybe render text, my reactive expression. And importantly, we don't just use it like it's a variable, we use it like it's a function call. And what's going to happen is this function call is going to always return the same results here, and then whenever input changes, it will update its result, right? And then anything that depends on it will also update its result. But now, if instead of just render text here, we had multiple steps where, it was do this computationally demanding thing, and then generate text according to some other input. If that other input changes, it won't regenerate the reactive expression here, right? So it allows you to separate out these different components. Now, reactive expressions, so my reactive expression here, can only be called within reactive, so within the actual reactive function, or within render functions. You can't just call them outside of it, and Shiny will give you an error if you try to do this, right? So these can only be used within it. You can't just use them as a basic function call inside of any environment that you want to use them in. Now, those are sort of the main, even advanced features of Shiny, right? Reactive expressions sort of allow you to do a whole lot. Beyond this, it's just sort of getting familiar with all of the different components that we've been talking about, with how you actually go about constructing these different applications and such, right? So let's say that you've actually gone off and built this. Now what do you do, right? How do you actually get this shared and published? Well, the first easiest way that you can do this is you can just share your app.r and then whatever related files, and other people can run this for themselves, right? And as long as you've specified a self-contained directory, then they can download that directory, open it up themselves, and then run it, right? And so that's sort of the easiest way about going through this. It does require that others know R sufficiently well. And it also requires that you have a good way of sending these files back and forth. As an alternative, that still requires them to know R, but where you don't have to send these files, is you can actually upload a zip file to a website, or you can upload all of your files to a GitHub repository, right? And GitHub is just a public-facing, free-to-use place that you can store code, and so you can sort of place all of these onto your GitHub repository. Or you can put the app.r content into a GitHub gist environment, and GitHub gist is going to just be sort of a place that you can paste code anonymously almost. And then if you've done any of these three alternatives here, then Shiny has a way of running applications from the distance, right? So you can call Shiny run URL, paste in a URL, and if that has a zip file, it will run that as though it's a local zip environment. If you do run GitHub and you provide the GitHub repo link, then it will run this off of the GitHub. And there's a run gist, which is going to be provided here. There's sort of a typo in the syntax here. You just provide the GitHub gist number there, right? And so you can do these where the user still needs to know R, but they don't need to actually download the files directly from you, right? So this sort of provides one way of doing this. Alternatively, we can use shinyapps.io. And this is sort of where I've placed my files, right? So shinyapps.io has a free plan that you can sign up for. You can go to shinyapps.io, sign up, then you can just sort of generate an authentication token. You put that into your RStudio environment, and then there's a publish button directly in RStudio, and that will publish directly to shinyapps.io. You can go in, change the URL, these types of things, but then you can just pass someone a link to this URL. And if you really needed to, you can sort of end up running the servers yourself or doing any of these sort of more complex situations, but especially for within this class and for, sharing these types of small projects amongst yourselves, shinyapps.io is probably the easiest way to go about doing this. And again, their free plan should be more than enough for anything that you're doing at the basic level. And by the time that you're doing things that are a little bit more advanced, then you are going to be able to sort of look at the other alternatives and assess those for yourselves. So I will end up doing sort of a live demo walking through some of this, but we'll save that for a little later on. And so to sort of recap, you should take a look at the Shiny gallery. So the link is again on these slides here. There's going to be lots of inspiration there for different applications you can create. It'll show you a whole lot of the different tools within it. It will also give you the code for all of these Shiny applications, right? And so then you can sort of download them for yourselves, actually start playing around, seeing how people do a different thing. As a sort of, to reiterate the point, you want to use that directory, right? So you want to specify the main directory. Shiny is going to treat all paths as relative to this main file, right? And so you want to sort of reference everything off of your app.r. This is important because probably Shiny apps will be some of the first applications that you're hoping other people are going to be running, right? This doesn't just need to work on your computer, it needs to work for other people too. And so it's just important to make sure that you're not referencing stuff that's just hiding elsewhere off in your computer. By default, Shiny will include Bootstrap. If you know what Bootstrap is, this can be really useful for you. It's sort of this framework for HTML and CSS. And so if you're familiar with Bootstrap, Shiny is going to behave according to that. If not, you can take a look at the Bootstrap link linked off here, and that will sort of provide you some better sense of how Shiny is going to go about laying out things. Generative AI tools are also very useful for Shiny, right? So if you go into ChatGPT and you ask it to lay you out a Shiny application, because Shiny really is specifying layouts and then hooking them up, right? The actual specify the layout component before you start providing the specific logic is something that's sort of very repetitive. And there are all sorts of different tools that have cropped up to sort of help you lay out Shiny applications, right? And you should look into some of these. Maybe I'll post some towards the class website. But overall, it's this repetitive procedure. And because it's this repetitive, sort of well-defined procedure, generative AI tools are also going to be quite good at doing that. And so I would encourage you to also just go into ChatGPT and say, hey, can you build me a Shiny layout that's going to have, a sidebar with these controls and a place to output a table, right? And it will just provide you that code directly. And then from there, you can start doing the more interesting components of actually hooking those things up. Right. So that's essentially everything that I wanted to talk about in today's lecture. I know it's a lot of content. Hopefully it makes some sense. Please feel free to reach out to me to talk more about any of this. But then I would just encourage you to get into Shiny, start playing around with it. It's a really, really powerful tool, and the applications you make from it are always going to be impressive to people, right? And it does not take that much work to start making out some of these cool data science applications. So thanks for listening to this, and I will see you all in class very soon.